Okay, this video is going to be the first video where we solve by linear combinations, which is also sometimes called solving by elimination or solving by addition. All three of those things mean the same thing. This is our third method to solve a system of equations. So far we've learned about solving by graphing and also solving by substitution. So you can use any of the methods to solve any system. The advantage to using elimination or addition or combinations is that sometimes we get a system of equations where the equations are not set up nicely to graph, and they're also not set up very nicely for substitution. And that's this case. These equations right here in this system are set up in standard form, and it would take a little bit of effort to get those into slope-intercept form so we could graph them, or to solve for one of the variables so we could use substitution. So instead we're going to use the method called elimination or addition. So one reason that it's called elimination sometimes is because when you add the two equations together, you are going to eliminate one of the variables. That's why it's called elimination. And why sometimes we call it addition is because the method we're going to use here is adding these two equations together. So watch what happens when I add these two equations together. Just like when we've been adding or subtracting something to both sides of an equal sign to solve it, we're just going to add down, everything add down. So 3x plus 2x is 5x. 2y plus negative 2y is 0y. We have eliminated, that's that word, eliminated the y variable because 0 times y is 0, so we no longer have a y variable in this equation. And 14 plus negative 4 is 10. So by adding these two equations together, we have eliminated one of the variables, and now we know that 5 times something equals 10. If we divide both sides by 5, we find out that x equals 2. Don't forget, though, that we are trying to find the point where these two lines intersect, and a point needs an x and a y. And so far, all we've learned is that our x coordinate is 2. To find the y coordinate, you can take this 2 and substitute it back into either one of the equations. It totally doesn't matter, whichever one. I'm just going to put it in the first one. So 3 times 2, because we know that x is 2, we're replacing x with the 2, plus 2y equals 14. And now we can go ahead and solve for y. 3 times 2 is 6. 6 plus 2y equals 14. If we subtract 6 from each side, we get that 2y equals 8, and then that y would equal 4. So that tells us that the y coordinate for this point is 4. And so we have solved this system of equations by the elimination method. We added the two equations together. Now, if you're wondering why you're allowed to do that, remember that we could add anything we want to both sides of an equal sign and preserve this. And so we're doing it all in one step, but we're adding 2x to both sides of the equal sign, and negative 2y and negative 4. It's just a shortcut. We don't need to write out all those steps. We're just adding these two equations together, and by doing so we've eliminated a variable which helped us to solve for both of them. Let's do the example from your classwork. This is number 4 on the back. I'm not going to go in order for this classwork. I'm going to start right here with number 4. So we first look at this and we can tell right away that it's set up nicely for the elimination or the addition method, because you can tell by looking at these two variables. When we add the 3x plus negative 3x, that's going to add up to 0. So you want to look for coefficients that are the same, that have opposite signs. So when we add these two together, everything will add up to 0 and we'll eliminate a variable. So negative 3x plus 3x is 0x, and we have eliminated all of the x's. Some people like to draw a line through them like that. Or some people say cancel. I don't love that word, but we have added the x's up and they equaled 0, so we've eliminated them. Now 2y plus negative 5y is negative 3y. We're just adding column by column. And so negative 3y equals, we're going to add this column together, negative 19 plus 25 is 6. Now we have a simple equation to solve. We're going to divide both sides by negative 3. And when we do that, we get that y equals negative 2. So remember, you want to set up your parentheses and a comma, and what we just found is the y coordinate, which is the second one. So y equals negative 2, and we are not finished. We still need to find x. You can take this y, now that you know that it's negative 2, and plug it back into either one of these equations. It doesn't matter which one, but we're going to plug it back in for y and solve for x. So this time, just for fun, I'll put it in the second equation. That means that negative 3x minus 5 times negative 2, because y equals negative 2, is going to equal 25. And now we're going to solve for x. I'm going to multiply negative 5 times negative 2, and that gives me positive 10. And if I keep solving to get x, I'm going to subtract this 10 from both sides. That tells me that negative 3x equals 15. And now if we divide by negative 3, we get that x equals negative 5. So we have found that our x coordinate for this point where these two lines cross is at negative 5. And that's our answer. This entire point right here, is the answer, with the x equals negative 5 and the y equals negative 2. Okay, let's look at number 6. It's similar. We first want to look at it and decide, hey, is this set up nicely for the elimination or the addition or the combination method? And we can tell by looking at these coefficients that because they are the same number with different signs, when we add these two together, they're going to add up to 0. They're additive inverses. If you remember learning about that a long time ago in Unit 1. So let's add these two equations together. 2x plus 4x is 6x. Negative 5y plus 5y adds up to 0, so we have eliminated all of the y's. And then negative 28 plus 4 equals negative 24. Remember, we're adding column by column to figure this out. Okay, if 6 times something equals negative 4, or negative 24, and we divide both sides by 6, then we get that x equals negative 4. Are we finished? No. We have only found our first coordinate, and that's negative 4. To find out what y is, we're going to plug negative 4 back into one of these equations to solve for y. We already know that x equals negative 4, so if I stick it in the second equation, I get that 4 times negative 4, because x equals negative 4, plus 5y equals 4. Let's go ahead and multiply. 4 times negative 4 is negative 16, plus 5y equals 4. Let's add that 16 to both sides. When we do that, we end up with 5y equals 20. Divide both sides by 5, and y equals 4. So if x equals negative 4, then y equals positive 4. And that's our answer. That's the point where these two lines intersect. Okay, now sometimes when we have these equations, like for this one for example, if we were to add this column up, we would not actually eliminate the y's. And if we were to add this column, we would not eliminate the x's. Nothing here will add up to 0. So you might think, well, I can't use the elimination method. You have to make sure you eliminate a variable when you add them. Otherwise, it's just going to make this way more complicated and you're not going to get the answer. So sometimes what we have to do is remember that you are allowed to multiply any equation you would like by any number you'd like except for 0, as long as you multiply every term by the same number. So what would happen here if I multiplied this second equation, if I multiplied everything there, that's not an x, that's multiplied, by negative 1. If I multiplied everything in this second equation by negative 1, I would have a negative 4x, a positive 2y, and a negative 18. Why did I do that? because now when I add this second column together, these two will add up to 0, and I will eliminate the y terms. Remember, that was our job. We're calling this elimination because we want to eliminate a variable. And you are allowed to multiply any equation you want by any number that you want, as long as it's not 0. So let's go ahead and solve this. If we add these two equations together, after we have multiplied 1 by -1 like that, 6x plus -4x is 2x. Negative 2y plus 2y is 0y, and 32 plus -18 is 14. And that tells me that x equals 7. Now, another method we could do here, instead of multiplying the whole thing by -1, I'm going to erase all this stuff and go back to the very beginning when we were looking at this. Instead of multiplying by -1, I'm just going to subtract these two. I'm going to think about this, well, if I add them together, I won't eliminate anything, but what if I just go ahead and subtract this second equation? That will, subtracting 4x, that means I have to subtract everything in that second equation. I have to say 6x subtract 4x is 2x. Negative 2y subtract -2y is the same as -2y plus 2y, which is 0y, and positive 32 subtract 18 equals 14. So if you would like to think about this as subtraction instead of addition, that's totally fine. Either way, we're going to end up with x equals 7. But you remember that we're not finished until we find x and y. So I'm going to take x equals 7 and I'm going to replace it into the first equation. You could choose to do it into the second one. You'd get the same answer. So 6 times 7, because x is now 7, minus 2 times y equals 32. 6 times 7 is 42. And to solve this for y, I'm going to need to subtract the 42 from each side. That leaves me with -2y, don't forget to keep that sign in front of the number, equals -10. 32 minus 42 is -10. And now if I divide both sides by -2, I get that y equals +5. So I found that if x equals 7, y equals +5. Now, I want to show you how to check your solution, just to make sure that we got the right answer. So I'm going to go ahead and just erase this work that I showed right here, and let's check our solution. You should be able to check every solution that you do and make sure it's correct before you go on to the next problem. So in order to check this, we need to remember that this is the solution to both lines. And if it's the solution, that means that x equals 7 and y equals 5 will both work properly in each equation. So I'm going to check this first equation. I'm going to replace the x with the 7 and the y with a 5. And I'm going to ask myself, does this really equal 32? If it does, then it's a solution to this line. So 6 times 7 is 42. 2 times 5 is 10. Does 42 minus 10 equal 32? Yes. So that's correct. 7, 5 is a point that's a solution to that first equation. Let's check our second equation. This time we have that 4 times 7 because x equals 7 minus 2 times 5 because y equals 5. We're trying to find out if that does equal 18. Well, 4 times 7 is 28, and 28 minus 10 certainly does equal 18. So you can see by that work that we've done to check that this point is a solution to both of these lines. In fact, it's the point where these two lines intersect or cross. All right, let's do number 5. This is another one where we might need to subtract instead of add, or if you like to think about it as multiplying by -1 and then adding, that also works. How do I know that I should be subtracting instead of adding? Well, my first clue is I'm just going to try to add these together column by column. 7x plus 7x is 14x. Wait, I didn't eliminate the x's. 4y, if I add this column, 4y plus 2y is 6y, and I didn't eliminate the y's either. And the whole point of this is to get rid of one of those variables so I can solve for the other one. If I add them together and I haven't eliminated a variable, that's a big clue that I need to fix something. I either need to subtract or multiply by -1. Whichever way you want to think about it, it basically means you are going to have to change the sign of everything in the second equation and then add them together. So now 7x plus 7x equals 7x plus -7x equals 0x, which is just 0. 4y plus -2y is 2y. And 2 plus -8 is -6. Now we can divide both sides by 2 because 0 times x is just 0, so that's doesn't change anything, it's insignificant. And this tells us that y equals -3. Are we finished? No, we need to remember that we have only solved for half of it. All we know is that y equals -3. We need to choose one of the equations to figure out what x is. Now again, it doesn't matter which equation you choose. I'm just going to choose the first one. 7x plus 4, and instead of y, I'm going to put -3 in the parentheses because I know that y equals -3, so I can replace that. And this whole thing equals 2, just like in the first equation. So that gives me 7x minus 12 equals 2. Adding 12 to both sides tells me 7x equals 14. Divide both sides by 7, and look at that, x equals 2. X equals 2, y equals -3. That entire point with the x and the y is our solution. All right, let's look at number 1 on the front page of this classwork worksheet. It's a story problem, kind of a real-life problem, and so we're going to go through this pretty slowly because I know a lot of you struggle with how to set these up. It says, Will bought 4 packages of candy bars and 2 packages of cookies for $20. Tanya bought 5 packages of candy bars and 2 packages of cookies for $23. How much does 1 package of candy bars cost, and how much does 1 package of cookies cost? You need to figure out the answer and write a pair of equations. Now, the first thing that I want you to do for every word problem, always, is to define your variables. You need to tell me what your letters are going to stand for. That's going to help me understand how much you know and to see if you're actually understanding this correctly. So a trick that I always like to use is when you have to define your variables and you're not really sure, something helpful is to look at the question at the end and find out what we're actually trying to find in this problem. A lot of times that will help you know what your variables should be. So the question says, how much does 1 package of candy bars cost and how much does 1 package of cookies cost? So we're looking for the cost of 1 package of cookies and 1 package of candy bars. So the cost of 1 package of candy bars and the cost of 1 package of cookies. We can define these to be any variables we want. I'm just going to say that the candy bars are x and the cookies are y. Now another trick to help you out with word problems is that each sentence in the word problem is often one equation. Sometimes you can break things down that way. So let's go back to look at the very first sentence in the problem. It says 4 packages of candy bars and 2 packages of cookies cost $20. So let's write an expression using our variable to just represent 4 packages of candy bars, the cost of 4 packages of candy bars. Well, if 1 package of candy bars costs x, then 4 packages of candy bars must cost 4x. So 4x would be the cost of 4 packages of candy bars. All right? Can you come up with an expression to represent the cost of 2 packages of cookies? So the cost of one package of cookies is y, so 2 packages of cookies would be 2y. That is the cost of 2 packages of cookies. Now, if you go back to look again at the very first sentence, it said that 4 packages of candy bars plus 2 packages of cookies equaled $20. Well, we know that 4x is the cost of 4 packages of cookies, and 2y is the cost of 2 packages of cookies. So 4x plus 2y is going to equal $20. And that's our first equation. Then if you look at the second sentence, it will help us write our second equation. This time we bought 5 packages of candy bars, so that's going to be 5x, and 2 packages of cookies again, so that's 2y, and the whole thing cost us $23. Now, we have come up with 2 equations and 2 variables, and we need to now figure out how much does each package cost. So I'm going to take these 2 equations and I've rewritten them this way. I used C for candy bars and K for cookies, but we're going to solve this the same way. So the first thing I can see here is that I want to solve this by the elimination method, except that if I were to add 4c and 5c, I would not eliminate c. If I were to add 2k plus 2k, I would not eliminate k. So I need to do some multiplication first, or think about it as subtracting. Either way you think about it, I'm going to have to subtract this whole second row. So 4c minus 5c is negative 1c, or x, depending on which way you want to talk about this. 2k plus negative 2k is 0k. Yay, we eliminated a variable. And now 20 plus negative 23 is negative 3. If negative 1 times c equals negative 3, that means that c is positive 3. That makes more sense than getting a negative, because how can you have negative packages of candy? You can't. So this tells me that the cost of 1 package of candy was $3. Am I finished? No. I still need to find out how much did the cookie package cost. Oh, stylus is not writing. Cookies, how much did they cost? Well, if I know that C equals 3, I can plug that into any of the equations that I want. Replace C with 3, so 4 times 3 plus 2k equals 20. Now 4 times 3 is 12. 12 plus 2k is going to equal 20. Subtract 12 from each side, and you get that 2k equals 8. So k equals 4, and that tells me that 1 package of cookies costs $4. Okay, next problem I'm going to do is number 2, Jenny and her pens and pencils. So she bought 4 pens and 3 pencils for $3.75. Then Bill bought 4 pens and 6 pencils for $4.50. Again, let's define our variables. Let's say that x equals the cost of 1 pen. And then y could equal the cost of a pencil. Now that you have defined your variables, you can go back and reread the problem and try to write some expressions. So what would be an expression for 4 pens? The cost of 4 pens. Well, if the cost of 1 pen is x, then the cost of 4 pens must be 4x. Plus, she bought 3 pencils. Well, if the cost of 1 pencil is y, then the cost of 3 pencils is 3y. And what was her total bill when she bought 4 pens and 3 pencils? That added up to $3.75. Now, Bill, he went to the same store, so they cost the same amount of money, but he bought 4 pens and 6 pencils, and he spent $4.50. So there's a couple of different ways you could think about this problem. I'm just going to go ahead and solve it right now by the elimination method. I'm going to subtract this entire second row from the first row. 4x plus negative 4x is 0x. There you go, I've eliminated the x's. 3y minus 6y is negative 3y. And $3.75 minus $4.50 is going to equal negative 75 cents. Dividing both sides by negative 3 tells me that y equals 0.25. Remember, this is money. This is the cost of a pencil. That's what y equals. Does it make sense that a pencil would cost 25 cents? Absolutely, that's a valid answer. But we still need to know the cost of the pen. So I'm going to plug the cost of the pencil, 0.25, back up into either one of the equations to find the cost of the pen. So I'm just going to do the first one. Let's plug it back in. 4x plus 3 times 0.25 is going to equal $3.75. Well, 3 times 0.25 equals 0.75. So 4x plus 0.75 equals 3.75. And now when we subtract 0.75 from each side, because we're trying to solve for 4x, we get that 4x equals $3. Dividing both sides by 4 tells me that x equals 75 cents. Is that a valid cost for a pen? Sure, that totally does make sense. So if you wanted to put your answers into an ordered pair, that would be that x is 0.75 and y is 0.25. But you could also just come up here and tell me that the cost of one pen is 75 cents and that the cost of a pencil was 25 cents. And another way that you could have done this problem, besides over here we multiplied everything by negative 1, well, you could have just subtracted. Or you could have thought to yourself, well, he bought 3 more, and so what was the difference? The difference was 75 cents. You could have come up with this a lot of different ways. I personally like to use elimination as often as I possibly can because it's so much faster. And don't forget the other 2 ways that we have learned to solve. We're solving by graphing, so you also could have graphed these equations, solved by graphing, or you could have solved by substitution. And that would have been a little bit more difficult for this problem, but those were the other 2 ways that we have learned how to solve these problems.